Okay. So again, we are here. Let me go back here. All right. And as I mentioned to you before, it's interesting sometimes to have this situation. And basically what this means is like when you divide a number by as an integer, let's say 12 divided by 5. What kind of you can imagine in the real world is you have like 12 oranges and you have bags can fit only 5 oranges. So the question is how many bags I can put 5 oranges there. So how many bags? Bags is something that is an integer. You're not going to say 2.5 bags. You're going to say 2 bags can fit 5 oranges. So this is what we call division by integers, is how many fives I can get from this group. So I can have, in this case, 2 5s, right? 2 groups. So I can put in a bag, 2 bags. I can put 5 oranges right here. All right, so 2 of them. And the remaining is how many on that table that had initially 12 oranges. How many oranges will be without bags? So that's basically what you have. And again, why this is important? Well, there are many situations that you can use this in your benefit. And one example is right here. You go to the bank with those big jars full of coins and you give to them. They go through, they process, and they say, you have $1,234. And then they want to know how many $100 bill they are going to give you, how many $50 bills they are going to give you, 20, and so on. Everybody understand? So we can take the advantage of division by integers to do that for us very easily. Can someone tell me how many bills of $100 I can get from this one? Yes, 12. How do you do that calculation using that division by 0? What we would do?
That we have 1200s there. So you can only have 12 like $100 bills. So the 34 is just ignored if you have like it's like same as how many bills would be $1,200.
Yeah. So in Java, how do you do this calculation using divisions?
34 divided by 10.
10? 100, right? And that's it. You are kind of putting a back. You have all these points, and you are removing in bags that fits $100. So a bag of $100, another bag of $100. So I'm removing from this table, fictitious table here. I'm moving and I'm creating these bags with $100. That is the bill, $100 bill, another $100 bill, another $100 bill. So it's the same case as this one. So by doing this exactly this, you're going to get 12. Everybody understands? Now, what is in the table, what has left is my remaining. So what I'm going to do here, I'm going to create another variable, say remain. And is what? Is everything that I took off and put in the bags is the remaining on the table. So what I'm going to do is exactly the same calculation, but instead of use division, we use the percentage sign. In this case, just looking, how much is going to be the remaining? Yeah, 34. Everybody understands? Now I can repeat this process over and over, doing what? Now for $50 bill. So what I'm going to do is I'm just going to copy this just for the sake of saving time. Here, instead of 100, I'm going to put 50, and I'm going to divide 50. However, it's not the total dollars that I need to divide by 50. It's what was on the table yet, right? So it's the remaining. So I'm going to put the remaining here. That was 34. divide by 50. Can I fill a $50 bag with what remaining? No, it's not going to be completely full. So because it's 34, right? The remaining from the previous operation. So I'm going to get 0 bills of $50. That's basically what it's saying. And if there was some money there, you know what? Let's put 84 here instead of 34, 84. By doing so, I'm going to get 1 bag of 50. So this value here will give me one bag of 50 is got the cashier is going to give him one $50 bill. The same thing here. Now I remove 50 from that table that was 84. How many dollars I still have in that table is whatever is in the remaining. Remaining is remaining modules of 50. Now the remaining has been already used here. This is a temporary box. So I don't need to call this remaining 1, remaining 2, remaining 3. You just remove the definition. We are just reusing a box. Like you do when you move your stuff from dorm to dorm. You buy a box, you use, put it there, you save that box. When you move to another house, you can use the same box. So basically that's what we're doing here. We are just reusing a variable. But now you can keep doing the same thing here that I'm showing you with a $20 bill, $10 bill, 5, 2, and 1. Any question? And that's very easy to do, and you do with the division by integers. Another thing that you can do, and is one of your lab activities, is sometimes Westinghouse. 20 years ago when I joined Westinghouse, we used to track down a neutron in the core 1,000,000 times. You need to use Monte Carlo to get statistic values with some significance. So we need to track it down, and there is a probability that you're hitting with an angle, then you do another probability 1,000,000 times. Sometimes we run the code, we go home, and not go home, but in a week you get the results. Now it's like 10 seconds or so because the computer are much better. But we need to know how long it took. So the computer normally, in any language, I think it's like that, C++, Java, they give you the time of the process in a total of seconds, like 10,342. Now, if I go to my manager and he say how long it took, and I look at the manager and say 10,342, he's going to look at me like she's looking and say, what? What does it mean? You know, how many days is there? How many hours is there? So you can do kind of the same thing. You can use this total seconds and start dividing by 3,600. That is the number of hours. So you know how many hours, then you go how many minutes and how many seconds, the same thing. Everybody understands? Painting a room. I want to paint this room. So what is going to happen? I know the square footage of this room. I go to Lowe's. There are different types of cans of painting. There is the big one, little quarter ones, and very small ones. How many of each one I need to buy? Well, I can use division by integer for the same thing. I know that the big one covers so many, so I get this total, subtract that, divide by that, and then the leftover, I get a smaller one, and then a small one. Everybody understand? So there is a lot of things that we can do with division by integer. And that's the reason why we have those things there. Any question? All right, so we went through that. There is nothing else for math operations. There is always more things to do, but we are going to do this during the semester. We are going to, more and more, we are going to discuss those things there. Okay, and again, after doing all those things, you just print, like make a print statement, how many bills of 100, how many bills of 50, and so on. You just make a system out, print away, and you could get the values there. The cashier would give you the right amount there. All right, now what I wanted you to do, we are over with this math operations. Let me save this. Now we are going for if statements. So if you could go to, again, to Canvas. And on Canvas, the basic talks 02, you are going to get lecture material. We are going to have 3 zip files. You can download all 3 if you want. And again, download somewhere that you kind of keep things organized. So try to save in the same location as the other ones that you have. And then you unzip that. No, sorry, you don't unzip. What you do, you go to your NetBeans, click here, and you're going to say import project from zip file. So wherever you download it, you go there and import from zip file. That's what you do. And then when you do that, you're going to get it here like I have. That is this guy right here. Okay, so you're going to get this one here. This one, always we go for the source packages, and then if statements, and then the job itself is this guy here. That is this guy that I'm showing right here. Okay, so I'm going to decrease this guy. If it's extremely easy, everybody should know how to do if statement. If statement is you have a condition, that is this guy here, and if the condition is true, the if statement is going to execute what is in the curly brackets, that is the block. Everybody understands? Very, very simple. So let's start with the simplest one. You have 2 integers, age 1 and age 2, and you need to compare and see if the ages are equal. So what kind of a statement should I put on line 27? Yes. A equal B. Very simple, right? No problem at all. Let's talk about doubles. Now, doubles, imagine that I am running a factory, all right? I have a factory, I produce wheels, and the wheels must be in a quality control, and they need to be 20 foot, or 20 inches, right? And then I have a measurement, system there that as I produce, that thing is going to measure and give me some double there. And I need to compare my 20.0, that is my standard, with the measure that I got. So I know that I can sell that wheel or I need to reject that wheel because it didn't pass the control, the quality control. So how do I do that? So imagine here that I have again. I'm going to put 10.0 here. So this is the measure from my system, and this is my standard. What's the condition? Anyone? Yeah. It's greater or equal, you mean? All right. So if the wheel has the measure one is 25 inches, is it approved? It's equal. So let's try here. So you say, let's put this here. So I'm going to start measure. And one thing that is just something that is in NetBeans, if you start typing a variable, if you use the control key down and space bar, it fills for you. So equal is everybody agrees with that solution? No, why? All right. The problem is I have a scale here. that I created using some board, and that board, I programmed that board, and it's connected through Wi-Fi to the internet, and then I'm accessing a page. Where is the page? Should be right here. What is this? Is this guy right here? All right. And I produce water bottles. So I'm going to put here the water bottle right there. It takes like a 15 seconds to update the page. I normally do that. So let's take a while, see if it updates. All right. So here what you have is, all right. So let's give a second here. So let's say that my standard is about 200 grams. So this is my standard, all right? So this is what I expect to get from that measurement. But if you look at the measurement, it's 198, and all those numbers, most of them are noise, but it comes from my measurement. It comes right from the wire. So if I try to use equal, I need in my program, the standard needs to match all those decimal points there. It's impossible, right? If you can imagine that every two numbers there is the group of two, it's like a Powerball. So I need to match 6 or 7 Powerball numbers to make the if statement perfect, the equal. So I cannot use equal for double. Even though that you're going to be tempted, and some of your programs, it will work, you should not use equal when you compare double numbers. You understand? All right? So what he said is correctly in terms of what I'm doing here is what we call tolerance. And I don't know if you ever saw like a drawing, like a mechanical drawing. They put a value and they put plus or minus a tolerance, 0.5 inches or so. They put in any drawing because they know that can never match a value dot 0.000. They never can be done that. That is a tolerance. So if that number that I measured, the weight is 212 plus all this garbage there. If it is inside the tolerance of this standard, I misspelled there, then the quality control say, yeah, that water bottle is okay. Now, if I get a water bottle that was partially filled, something went wrong in my process, and I try to measurement, it should be out of the tolerance. And that's what you get there. So that's the thing that I want to show you here. So going back here, so how do we do that? We do not do this, all right? What we are going to do is we need to subtract one from the other. So I'm going to subtract here, minus. And I want this whole thing be less than a given tolerance. And the tolerance, you can put whatever you want. So double, it depends on your process, the measurement that you have, and so on. Let's say that the tolerance is equal. You can look at the drawing of your process, and you're going to see that the tolerance is that if the difference between what you measure and the standard is smaller than the tolerance, you're going to say that is approved. However, this works in one direction when when the measurement is bigger than the standard. But sometimes the measure is a little smaller than this will not work. So what you need to do here is just an update. You need to get the absolute value of that thing. So it doesn't matter if the difference is for less or for more, but if it's inside the tolerance, you are accepting that measurement. Everybody with me? Okay. True condition, it's raining. What do I need to put here? And I'm showing all these things again for the same reason that I told you before. Someone is going to interview with me and they show their code. If I look at the if statement and I see those things like comparing double numbers with equal, something is not right. And the same thing for Boolean. Depending on how they compare, I don't like it. So I just want to know how we do Boolean. Yes. Very good. So is Rennie. There are a lot of students, mainly in the introductory course, they are going to do equal to true. You do not need to do that because we need a condition that resolves into true or false, just that. So if you just say this part here, this is already a Boolean, so it's going to be true or false. So you don't need to say equal to true or equal to false. You just put it there. Everybody understands? All right? So I like to go through these things. It's just to remind you that even though if statement is very easy, how you do the condition depends on the variable type. Another thing is just an example here. Sometimes you have a method, for example, a string method called isEmpty. So you have an input in a GUI, the person press submit, and you want to check if some required field is empty or not. So you can use this isEmpty function that comes from the class string. We are going to discuss more about class later on, but what you can do, you can get the object name, and instead of say equal to empty like that, you can use dot isEmpty, and if I could ask something for you to take home from this class, is you need to pay attention what NetBeans tells you, all right? So this is the name of the function, isEmpty. The function requires no input, so you just put open and close parentheses, and the function returns you a Boolean. Great. A Boolean I can use in the if condition. So I don't need to do anything else. Just put if isEmpty here. It's going to return a Boolean that is going to say true if it's empty or false if it's not empty, and they can work on that. Everybody with me? All right. Two names. Name one, name two, John. I see a lot of people doing this. Is this right or wrong, and why? Go ahead, man. Say it again, please. Okay, how do I fix that? You need to speak it up a little bit.
Sorry, I think.
Very good, very good. Now, one thing that we need to learn, and why not, let's mention this now, is, what is my, it's always good to mention, why not? I always try to make a correlation with the real world, right? So when you say here, int a equal 10, basically what you do in real world is you go to U-Haul, you know the box size because you know that it's an integer, so you get a box size that is going to fit an integer. So you get a box, all right, box. In the box outside, you're going to get your 10 and put A, so that's this. So the box size, the A is the label outside, and inside, you're going to put 10. So if I go home and I open that box and look inside, I will see the number 10 wait for me, right? Now, when you say string name equal John, string can be very big. You can make like a 2 pages of a book, even more. You can make it between the double quotes. You can put it there. Now, can you fit all these 2 pages or a whole book of a string? Can you put inside a single box? No. Okay, so what happened is, this is a class called string, and we're going to learn more about this. But if you do a string name equal John, what happened is the Java is going to create a box. It's going to label the box name. But when you open this box and you look inside, you are not going to see John waving for you, that name. What you're going to see is what? If anybody knows. Yes. The address. Very good. Is the address in another place in the memory that he can fill, Java can fill a big chunk of letters. Can be just John that is 4 letters, or can be a whole book. Doesn't matter. But what you have there is a location in memory. Something like that. That's what you're going to see waiting for you if you open that box. Now, when you create another box, string name 1, and then string name 2, and you put John again, doesn't matter. It's going to be create a second box. Java virtual machine is going to find another location in memory, and it's going to put the address inside this box. So it will be X like a 4 AAF or something like that. So when I compare strings with equal, Java virtual machine is open those two boxes and compare what is inside those boxes. What is inside those boxes is this guy here. So even though these guys are pointing to different locations, but the locations have John, what Java is really comparing is these guys inside those boxes. And this is completely different. Everybody understands? Now, I said all those things. What happened is Java, many years ago, this is a so common error by programmers that that's the only exception in Java. You can compare strings equal. Because it realized that you made the mistake, they are kind of forgive you, and it's going to go after the location that is inside that box and not comparing them. Now, when we create another class, like a car class, TV class that we are going to create in this course, you cannot do that because they are not going to be forgiven in this sense. Everybody with me? So why not? Let's use the correct way of doing. That is, as someone said, you're going to say name1 dot equals. There are two equals. You can use just the equals, or you can use the equals ignore case. In this case of equals, if John and the other John, they have the capitalization correct, needs to be correct to be equal. Or if the second John is the J is lowercase, and you want to be equal, you can say ignores case. So that's what I'm going to use here. So that's the right way for the conditions for a string. So even though we start with if statement, that is the simplest thing that we can do, you realize that the name of the variable, we have 4 different conditions. And amazingly enough, is something that when you are a programmer many years, as soon as I hit my eye, I know how much you know in Java or any other language. Just look at it, he missed that thing. All right, everybody with me? All right. Another thing about if statement, very simple. This is, I'm going to go fly here, is sometimes you have just one option, so just one path, or you follow that path, or you skip it. You kind of jump that hole, you jump and keep going so you don't execute. So if you want to apply a discount, if you're a veteran, you do, if that happens, you apply a discount. So you just multiply by 0.9 the final purchase or order or something. Or if it's not a veteran, you just skip the application of the discount and you just continue your program, right? Now, sometimes you have a 2-path that you can go either one or the other way, but you need to follow one of them. So this is just a quick example here. You're tossing a coin. If it's head, so you start the game. If not, I start the game, something like that. So you can use the if and else. Now, sometimes you have more options. Instead of just 2 paths, you can have multiple paths, 3 or more. Then in this case, what you need is you need to have in between you need to have another else if. You need to have a second condition here, and then you do like this. Nothing new here. Does anybody has any question? I'm going to go very quickly here. All right. So this is the if statement. Now let's go for while loops. Why not? Let's go for loops. How many loops we have in Java, Python, and C++? How many loops?
3.
What are they?
If I forgot that one.
Okay. Yeah. 4. Sunday. The for loop and the while loop. The if is not really a loop.
Oh, yeah.
Loop is like a repetition of some text, right? So you have a while loop that is going to repeat, and you have the for loop. Now, the real question is, when do I use a for loop? When I use a while loop? Does anybody? I'm just teasing. Yes. Yes, and the while loop you don't, right? Very good. Example, very simple example. Real world example again. I am in a building, I need to go to the stairs. I cannot use the elevator, and I need to go to the 5th floor. I know exactly where I want to go and how many times I need to go over the ladder. 5 times. So go 1, did I go there yet? No. 2, go there? No. I'm checking with something that I know how much is the limit. It's 5 in this case. Another example, for example, for a while loop, I'm sitting with my car in the traffic light. I'm going to take my foot from the brake and put in the gas when the traffic becomes green. Do I know when it's going to happen? No, but I keep checking. Can take 1 minute, can take 2 minutes, doesn't matter. But as soon as it takes, the condition happens, I can go forward. Everybody understand? So one, I know exactly when it happens. The other, I do not when it happens. But when it happens, I'll do something. Or in this case, in the loop, I keep my foot on the brake while it's in red. Everybody understand? So that's the main question that I could ask someone at the very beginning, like, what's the difference between for loop and while loop? The for loop, you know how many times you're going to do the loop, and the while loop, you don't know how many times you're going to do. All right. Again, let's use something practical. Just as exercise, I like to do something like you could do in the lab or some research. So let's talk about this very quickly. What equation did I use here? This one. When we say solve this equation, what do we mean? We need to do what? What we need to do?
Find X.
All right. So how do we find X here? So we just isolate, right? I'm going to put X that way. So it's going to be 4X equal 2. So X equal 2 divided by 4. X equal 0.5. What does it mean? X equals 0.5. It means that if I get this 0.5 and I plug in this function and I put 0.5 and I apply on this function, this value is going to be equal to this value. And we can check 0.5 is divided by 2, right? So 5 multiplied by divided by 2 is going to be 2.5. 2 plus half, that is the value here, I get 2.5. So we analytically, we were able to solve this problem. So far, so good. Very easy, no problem at all. Now imagine in your research, you end up with 2 equations that they are not easy to do it by hand like we did. So imagine that I want to like 2x squared plus 5x minus 3 equal to sine 100 times sine of x, something like that. And I want to know what x makes one function equal to the other function. Everybody understands? That's the main idea. Sometimes you try to isolate x, it's going to be very hard in this case, right? So what you can do is you can change x all the time in computing this guy, until you kind of get the value here equal to this one here. So you have something like this is a quadratic equation, and this is sine, right? So I don't know, something like that. So you want to know this position here, if this is x, you want to know which x you make this function equal to this other function. Everybody understands? So that's what we can do. And how can we do? We can use the while again. How so? I know this equation, and what I need to do is increment this x. So I'm going to increment by 5, and then 10. Keep going. And I check that this is under this one here. And then suddenly this is above this one here. So I know that I was here and I passed here. Now what happened is I kind of overshoot too much. So the precision might not be good. It's not that close to this point. So what I do when I'm past, I can invert. Instead of keep going adding x, I can subtract x. Instead of giving 5 on 5, I can say 2.5, but in this direction. So I'm going small things here until I cross again. When I cross again, I can divide it by 125 or so. And then I go back, and then I keep bouncing it until it gets the precision that I want. And then I say the x that satisfies this graphically is this way. Everybody understand? And this could be a while loop. I just toss it there and say, keep going until the difference between one function and the other is smaller than 0.01 or so. Everybody with me? And this could be application of a while loop. And that's what we have here. So if you see this example here, I have two functions. So function 1 is this guy here, 10 times sine of x, x in radians. In this case, all the equations, when you go to libraries in Python or in Excel spreadsheet or in Java or in C, normally you need to provide x not in degrees, like 90 degrees. You need to give like a pi over 2 or so is in radians, but that's okay. And the second function is just in degrees. This is the second function, that is the quadratic function. And what I do is I'm going to increment the x. I start from 0, calculate these two functions, see the difference. The difference is bigger than the tolerance. Then I keep increasing until the difference inverts. Then I go to the other direction with a smaller, and I keep trying to find in a good tolerance. So that's basically what I'm doing here. So I start from x0. The precision in this guy here. So I wanted these two functions to be as close as the difference, smaller than this. This is just the condition for the while loop. Keep searching. When I eventually find a number x that meets my criteria, I want to quit the while loop, right? So the while loop is like that green light, the red light. When I get the green light, I stop looking at the traffic light. Here is the same. When I get this tolerance, the difference less than the tolerance, the precision, then I will change this flag to not keep searching. And here is my while loop. And basically what I do is in the while loop, I calculate function 1 and I calculate function 2. It's exact same here, right? I calculate this guy, get a number. I calculate this guy, get a number, and I check then the difference. So that's what we are doing right here. I do the diff, and then I check if the absolute of that number is less than the precision. If it is, we just set that flag condition to false, and this loop will stop when it reached the bound here. And I just print the parameters, and the parameters that I'm printing is, what is that? Is the position, how much is function 1, how much is function 2, how much is the difference, and how much is the delta. Remember, the delta I will change over the search. When I pass the first time, I will decrease the x, so it go smaller and smaller. And so I'm printing this every time that I do that. And then here is just, again, checking if the diff is greater than 0 or smaller than 0. Then I will change the delta to positive or negative and divide by 2. So the interval, instead of being big, positive, is going to invert, make it divide by 2, and negative. So it's going that way, and then eventually goes back, decrease by 2, and go that way again. And I keep bouncing back and forth, and that's it. And I updated the current position. So if we go through that, save. So this is x, the x. This is the y1 and y2. So again, the same sign is 0. And this guy, I think, is the quadratic equation. The difference is huge. And the delta is this one. So I keep going down, and the difference is always positive. But the two functions, this one and this one, it's kind of changing as I show in the plot. So eventually what happened is, look at here, the difference starts decreasing the size, and eventually one curve cross the other. So the difference now is negative. Oh, it's negative. Okay. So the delta, instead of being 5, now I'm going to say minus 2.5. So I'm going back, and then I keep bouncing. And you see that it's going back and forth here. And eventually, this is the number that I need to plug in that equation to get the two functions equal. Everybody understands? Any question? So just again, it's just a simple case why we use while loop. This is one example. Second example of while loop, very simple. This example is good because you should use all the time in your project, all right? You have an input. The input is through the keyboard, and you're asking the customer of your that is using your program to give an input from 1 to 5. So I'm driving through, all right, McDonald's, and the meal numbers are from 1 to 5. So I can choose between meal numbers 1 to 5. So here is my card. How do you call the guy that is in the window? The guy from the McDonald's, right? And I'm with my card here and say, what order do you want? No, you ask me. I would like number 7. Very good. And then what's your question again?
Yeah, what would you like?
All right. And I say number -2. And you're going to say? Very good. So how many times we are going to do this dance? As many times needed for me to come up with the right number. Everybody understands? So this is very important for input validation. So whatever program you are running, you need a pressure in a system, and you know that system runs from a pressure from 100 psi to 500 psi, nothing outside that range. And you need the user to type a number. If the user does not type the right number, you keep asking, like the McDonald's guy. Everybody understands? All right. So number validation or input validation is normally used a while loop because you keep asking. You could use a for loop if you are like you don't want to play this for an hour, 2 hours. You can say 3 times you didn't do it right, next client. You could use a for loop. But in this case, I'm very insisting. So I want a persistent person. I want to do this multiple times. So basically here, I'm just giving you an example what we do. So here is, again, I have a Boolean variable that says a valid new number, and I'm setting to false. So the while loop is while not a valid input. And remember, the not here means that the false, not false is true. So this whole condition here is going to be true. Because it's true, it's going to execute this guy right here. And what we want to do is ask for a mu number. And then I get the mu number from the keyboard, and I check if the mu number is either less than 1 or bigger than 5. It is outside the range. So I'll say it's invalid. So mu number is invalid. However, if this condition is not true, it means that the person has entered the right number, like number 3. Then I just set this guy, the condition for the while loop, right? This guy here, I set to true, and then it's going to say not true becomes false. So this whole thing is going to be skipped by the Java Virtual Machine. And here you get the mu, the chosen mu is number 3. But while you don't provide the right input, you are going to get this annoying question saying you didn't provide, please provide the right number. All right. We are going to talk more about a keyboard, but this is the way to do it. We are going to use a class called scanner. This is part of the Java API. And as I mentioned last class, Java API is what? What is an API? What it represents in general? Very good. It's a library that someone has created with a lot of functionality. So thanks God for the Good Samaritan that has created those libraries, because we just use it. We don't care who did it, how long it took it. We are just using. All right. So scanner is a class that scans for the keyboard input, and we are going to go over more then. But basically, is what I'm doing. Where is this? Right here. I ask to enter a number from 1 to 5. So if you run this case here, let me this guy here. You see here, enter a mu number, and that's what I'm saying about input validation. If I say 9 and hit enter, it's going to say that it's not valid. Enter a mu number. I put -3, enter, and I can keep going with this dance for forever until I finally put a number that is valid, hit enter, and it's over. The validation is over, and then you can proceed with your process of doing all the calculations that you need to do in your program. So far, so good. All right. So that's important too. All right. For loop, there is nothing much there. Okay, we have 20 minutes. That's good. So let's go here. Again, you need to download the for loops. And the for loops here, you have something like this. So for loops, as we discussed, the difference between for loops and while loops is the for loops, you know exactly how many times you're going to do it. All right. And one good example is when you use arrays, and we are going to discuss more about array next lecture, but basically that's how you define an array. Is December high temperatures, for example. I just Google it here in Pittsburgh. That was the temperatures for each day in December. Now I want to know what was the highest value. For example, I wanted to apply some statistics. And how do you do in practice? So I have a box here of maximum value of temperatures, and I get one value, 30. Then I look at this box. Is 30 bigger than what is in the box? If it is, I put 30 there. Then I get another number here. It's 28. Well, this is 30. Is that bigger? No. So just regards. The next one. And I keep doing this. Oh, this one is 55. That is bigger. So I replace. So this box is always just one box. And I keep checking. If you need it, I will replace that. Everybody with me? Very simple thing to do it. But again, I need to go through all the numbers and do the same thing. What is that? Get the number, compare with this guy. If this guy is smaller, I replace it, get another number. So I'm repeating the same task over and over. It's a good candidate for a for loop. And that's what we're going to do. So very quickly here. The first number that I get here, I'm going to compare with the box. What should I put in the box? So I have the first number. The first number is 30 there, right? Line 20. I have 30 here. What should I compare with? If I'm using just one box, what is inside that box? Because it's the first number. What you can do, you can say, is the first number, the box is empty, I can put the number there. Or what you can do that many people do is, if I want the maximum value, I will put the minimum value that I can here in this box, because I know that as soon as I get any number, it's going to be bigger than this minimum value that I can. Everybody understands? All right, and we replace it. And that's what I do on line 23. Line 23, you can use, remember the double that we use for bytes and length that we did in last class? It's a class, and one of the parameters is minimum value. So it tells you a very, very small number, that no number can be as small as this one. So you put there, when you want the maximum number, you put the minimum there. Then what you're going to do is just a for loop here. So I'm going to say int current temp start from 0, because it'll be this index here, right? The first index here. Now you need to repeat how many times. You are going to say current temp less than, you could count yourself, okay? I could count blah, 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 let's say 30 inputs. So I can put here 30, and we are going to fix this in a minute. And then oh, okay, we could do that. However, this might come from a database, and the database may not have the 30 days, might have few days because the sensor was down or something. Depending on the month, you might have February 28. So hard coding 30 there is not a good option. So what's the option that we can do? Good. We can say to Java Virtual Machine, hey, Java Virtual Machine, can you kindly count for me the array? So what Java Virtual Machine say? Yeah, sure, I can count for you. You don't need to do that I'll do that for you. I'm a nice guy. So you can say Java Virtual Machine to count for you this array. So how do you do that? Instead of putting here 30, you're going to put the array that you want to count. So that is this guy here, Control copy, Control V, and then dot. When you say dot, the first number that shows, this first field that shows up there is length. And you see again that thing that I always want you to look at. On the right, you see int. So it's going to return the int that is the length of that array. So that's the best practice for you to do. You do not hard code an array size. You ask for the language that you're using to calculate for you. Python, C++, C, JavaScript, Java, all of them, they have very similar feature. Okay, so don't hard code a number like that. So that's what you're going to do. And what you do is that thing that I told you. I have a box with a number, very small number, and I have the number from the array, and I'm going to compare. Compare, always when I say check or compare, you know that I'm talking about if statement. So very simple there. And what we are going to do is if what is in the box. No, let's put the temperature first. So get the array here, and I need to get the current this is just an index that starts from 0. If this guy that is a number, in this case is going to be 30, is going to be bigger than what is in the box, right? What we are going to do, we are going to put in the box that number. So I'm going to get this guy back here. And that's it. And you keep doing this for loop for 30, or sometimes if it's bigger, this guy is bigger than that, put it there. If it's not, just toss away, get the next one in the array, is bigger, put it there. So eventually, when this loop is over, I can come here and just print the maximum temperature with what is in the box. You can do this for the minimum temperature, and you can do averages too. You just put everything in the box, you keep adding, and then at the end, after the for loop, you just divide by the number of points that you added there. So statistics, very simple to do with for loops. Any questions so far? Okay, let's try to do something fun here. Okay, what is missing? Oh, I always try to do something fun with hardware. So this is a hardware that I have here. What do you see? What is that? Yes, a LED strip, right? A LED strip. You see there, a lot of lights. I see as a programmer, I see another thing there. It's not a LED strip. I see a variable, I see an array, I see a for loop, and I see a while loop on this little thing here. I can see all those things just looking at that guy. I see all those things. And you have the knowledge already to play with these guys. You just need to know a little bit of hardware. That is not difficult at all. But the knowledge that you have with you already in Java, you can create something cool here, like what I just did here. But we are going to do ourselves again. And let's hope that it works fine. Where is the Arduino? Arduino is here. So Arduino is a platform that I can interact with the hardware. All right. So the hardware here, what I have here is I need to define how the number of LEDs. In this case, this little strip has 60. And there are many pins. The pin that is connect this strip to this board is the pin number 2. That is the only thing that you need to know. Then what you need to do is you can play with it. So basically what you create, as you see here, is an array of 60 LEDs. So I have an array of 6 LEDs, like what we had in the temperatures, all right? So I can program each of them individually. So let's program one individually. So what I'm going to do here is I'm going to try to set up one of them. So I'm going to put here LEDs. That is the array. Remember, this is the array. And I'm going to say, let's say number 5. That will be the 6 LED. And I'm going to say, I'm going to give a color for that. So I'm going to say this guy here, RGB, means red, green, and blue. So I need to give the 3 numbers. Let's try to put just red. So I'm going to put here and 0 blue and green there. So it's going to be just red. And after that, you need to turn that LED on. And I don't, how do I say? I don't memorize this command. So forgive me about that. That's why I'm reading here. And that's it. So let's try to see if let's hope that it works. Sometimes the connection with the computer doesn't go well. So let's see if everything is fine. It's compiling. So it's compiling my program, my computer, and then eventually it's going to download my program to that CPU there. And there you have it. Everybody understand? So I got one variable and I put the number right there. Now let's play. Remember I said that could be a for loop and while loop. So let's do it. I want to run this guy up to the last one. So this is a for loop. I go to one, turn it on. Go to the next, turn it off. That one, turn it on. This one. Go to the next, turn it off, turn it on. So I'm repeating the same process over and over for a limit time 60. So I can use a for loop for that. So that's what we're going to do. So what I'm going to do here is I'm going to do a for loop here. So int I equals 0. I'm going to put here, what's that, the number. With this I plus plus. And then here what I'm going to do, oops. I'm going to turn a LED, and this LED that I'm going to turn on is the one that is defined by the loop index, that is I, and I'm going to turn like this. And the previous one, LEDs, you know what, let's leave like that. Then we are going to see what happens. And after you turn it on, you need physically say to the hardware, now it's time to turn the LED on. So I said what LED to turn, and now it's turned it on. Now let's change the color. Let's get like a, say here, this one here, 255, and then show, and I need to close the loop here. Okay, so again, should do a loop here. So I'm going to compile, and if nothing goes wrong, look at that, we got that. And again, was too fast, so what we can do is create a delay here. So I'm going to create a delay. Let's put here, and then put a delay of 10. Just to not go that fast, right? So it's too fast, but you can do something like that. So that's one loop. So I'm going to put up to here. All right. Now what I want to do as I go, I want to clear the other one. So what we can do here is I'm turning this on, and I'm going to get the previous one, I minus 1. And I'm going to equal, then I'm going to see RGB, and I put no colors whatsoever. So we're going to do that. So I'm kind of turn it off because we are starting from 0. This is going to be negative number. It might cause a crash the program. So instead of 0 here, I'm starting from LED 1 here, just for now. So I turn it on the first one, turn it off the previous one, show the two of them, and then make a delay. So if we run this, we should be able to see. Is it going? Yeah. Okay. And stop it there. How do I go back? We went that way. How do I go back? Like a crab. How do I do that? My wife said that I'm a crab because when I need to take a decision, I keep maybe this way, and she says, stop being a crab, just take the decision, buy milk or whatever. So how do I go back now? Yes. There we go. So basically what I'm going to do, I'm going to repeat this whole thing here, Control copy, Control V, and here I'm going to, as he said, I'm going to start from the last one. So this is the guy. However, remember, the last one means 60. And in terms of index, Java use 0 as a starting point. So you need to subtract 1 there. Now I needs to be bigger than 0. But again, it's just a for loop, right? And then minus here. And again, what you need to do now, you wanna, this one, you need to turn it on. And this, the previous one, that I plus 1. needs to be 0. So let's put -2 here. I think that will do the trick. But again, what I put it here. Yeah, I think that's going to work. So let's try. It might give some error. So let's see. So it's going that way. We can change the timing. It's taking too long to do that. But look at that. Beautiful. Now, please come back to me. No, stop. So what we do? I want to run this for forever while my store is open. Just in a second. The whole day, I want this to be back and forth, back and forth. What we need to do. There are some usual people here that are raising their hands. I want to some other people. But we do. What do I need to change in this code to make the 2 for loops I put inside a while loop? So that's what we can do. So what we are going to do is right here on top, I make a while loop. I don't care the condition. I just want to put true here because really it's going to be for all day long. And I just want to just finish when I unplug from the wall. All right. So I can put a while loop here equal to true, hard coded. And then here I can put here close that while loop. And again, this 100 is too much. Let's put 20 and 20. And if we didn't make any mistake, did I get it? Oh, I got an error. Oh, yeah, it opened twice there. Yeah. Thank you. So it's going back and forth. Everybody understand? If you have ever seen Galactica, the Battlestar, you have that robot that does like this. You could do like this. So again, I always try when I'm walking, my wife makes fun of me. But whatever store that I come in and say, you know what, I can do this. You know what, I can do this in Java, or I do also a class in web programming. When I go to a restaurant, I have a QR code that gets the thing there. I said, oh, I'm going to give this as a project for the students. You know, and my wife says, stop that, Paulo. But I always, so anyhow. So that's the thing. It's about time. But yeah, next lecture, I want you guys to think about this one just before we go. With the knowledge that you have, and you're going to get a little more about this. Have you ever seen this thing here in the arena? Everybody saw that already, right? We can do that too, right? And just to show you. This guy, you see here, is exactly the same. You can do that too. So when you go to arena and you see that, I could do this if I have the money to do in a large scale. You can do exactly the same. Everybody with me? All right. Thank you, guys. See you Wednesday.